being inspired and taking metrics and inspiration from other work. And I think that's it seems to be something that's pretty common in the engineering community. Um, and sometimes I feel as if not everyone in statistics or data science is taking full advantage of that, where they're a little bit more um, regimented in what they believe actually can apply to them. But yeah, I was glad to see that. Are there any other examples that you've had where you've sort of cherry picked metrics or anything interesting that seemed to be useful?
No, that's a great point. One, yeah, because I think we do this a lot in the biomedical engineering because I think we're a somewhat younger engineering field. So I think, we're fortunate to see that, a lot of these other fields have done the hard work for us. So we can say, okay, you all figured this out. Let's do this. Um, but yeah, no, I mean, I think those are the biggest examples, but we're always trying to do this because, I think one of the things that, you talk about, everyone wants to move the field forward, right? You want to do something that's going to be new. And I think the way to do that a lot of times is really to kind of take a new approach to this. So, you don't want to just continue to say, oh, okay, we're always going to continue to measure the loading rate and see which one is higher. We really wanted to take a new approach to this. I guess it's more part of me that I get tired of reading the same paper over and over again. So I think that's where it comes about. But no, we're always looking for new ideas. And that's why I said it's been great is to pull from some of the statistics field. Like I said, I'm a biomedical engineer by trade. I'm not a statistician. But it's been great to, we try to pull in a lot of the work that you guys have been doing. So, and I think that's because of my background. My mother, is a statistician. So I think that's where it's all come from. So yeah, we're always looking, and that's why we go to conferences. The Joint Statistical Meeting is to gain a lot more information. So when we get back to these in person, maybe we can steal some more ideas.
Yeah, definitely. I would actually say that I think the engineering profession and sort of engineering research, they are pretty darn good about bringing statistics into the mix. It's just, I think a lot of statisticians somehow believe that statistics is like not available to the other technical fields, as if like the books are locked or something like that, where we just can't access them. And I think it is worth noting that not only do they, I mean, these days, not only are engineers very proficient at applying statistics, especially because most of our work usually has to deal with some type of stochastic process or another, but if you look at a lot of the best for a lot of, I wouldn't say best because obviously that's highly subjective, but if you look at a lot of the groundbreaking and cutting edge, like Bayesian machine learning work, it's coming out of engineering departments. And a lot of really good probabilistic machine learning work, it's biomedical engineers are doing it because the fact is, there was a time period where if you were doing some like mechanical engineering, there were these sort of heavily mathematical, deductive, I would just say lower variance phenomena that we had to study. And therefore, things like probability and statistics, maybe it might not have mattered as much as opposed to like the raw physics of the gear grinding or the rock hitting you on the head or something like that. I don't know.
Yeah.
Yeah, but now we are dealing with noisy processes, and engineering steps up its game because there's noise in this. There's no way that you could look at someone's gait and say, here's the like perfect physical system that produces this. Like, no, you're gonna have a noise process in that.
100%. Yeah, there's so many noisy processes. And I think also the addition of the fact that we can apply these techniques because I think technology has gotten better. So I know, like you said, in your work, you're able to collect data over days and times. And so I think that's the nice thing is that the ability to collect a lot of this data, we've gotten more sophisticated in our tools that we're using. So now we can start to get the right set of data that we can apply a lot of the techniques that maybe we couldn't before. So I think that's been big because even doing a time series of this, if you go back to like what Muybridge and biomechanics, all the stuff that we collect with the Vicon motion capture system and we get the ground reaction force and the knee angle stuff pretty instantaneously. They had to do by hand and digitize by hand. So I think, it was a lot harder. They were like, we're going to only analyze this one stride. We're not going to worry about 10 minutes of data to analyze. So I think that that's also a big part of this is just being able to collect these large data sets now.
Yeah, it really is impressive. And also it's I think that some of the scientific fields that aren't allowing you to collect as much of a big enough data set, they are limiting themselves because one, there are fewer hypotheses that you can test. And I do hit that one strong because I think that people should be aiming towards hypothesis-driven scientific inquiry. I don't like the idea, especially specifically within data science. I think it's very dangerous for us to just be doing data-driven data science because that's it's a little bit
Yeah.
inbred. Um, but yeah, no, I think that the opening up of these wearables and things like that. I guess sort of a wearable. What you have, it's like the dots are the wearables, but then of course you have all this other technology on top of that. But yeah, no, um, the amount that you can observe and test in the cool sort of machine learning analytical bits, which is obviously what we enjoy
Mhm.
probably the most. Like that's the most fun, engaging bit. That it does allow you to try and test out a lot more of those types of techniques.
No, 100%. And yeah, you're right about the wearables. I think the biggest thing about the wearables is, our system right now is not something that can be applied to the clinic. However, the metrics we can be collected in some of these wearables. So if we put in foot pressure sensors, they can collect those ground reaction force, the loading rate, the stride time. So, we have been testing them out experimentally, but yeah, the next step is really getting into these wearables, and that's what we like about them is it's something that we always want to be able to put into the clinic. And I think my collaboration with Dr. Brian Noren, who is a physical therapist, he would always say with us, because I think you're right. We would love to get into like, oh, we found this cool metric and we're delineating these things. And he'd always ask us, well, how are we going to apply this to the clinic? What is the physiological underpinning of this? What does this mean physiologically? So yeah, you're right. I think, it's not just collecting data and analyzing for analyzing's sake, but kind of doing it with a purpose. And so I think that's been great to work with other collaborators that kind of forced us to say, just don't throw everything in there and get a result, but make it something meaningful.
Yeah, I think that just playing off that last point, that when you look at things like biomechanics, where it is one of those fields where there's obviously there are some hard physical realities to it. There's a maximal bend to the knee. There's a maximal force that a human body can exert. There's a personalized maximal human force when you actually look at what the actual individual's body composition is. And so to me, I think that this is a very interesting area where it is very strongly both data science and good, like, bread and butter physical engineering, because you are taking all those principles. Did you have to learn a lot? How much like learning did you have to do uh on your sort of domain knowledge to get up to speed?
Yeah, that has been the biggest part is getting up to speed and learning all these things. So, like I said, this is not my training. So we've had to work with individuals like Heather Bush who was at the University of Kentucky. I know she's moved, but we have worked with a lot of individuals who have been in the statistics arena to kind of help us get an understanding of these tools and these measures and how they can be most appropriately applied. And so I still think we're still in that learning phase. I think the AR modeling, for example, we're really excited about that. But even like you're saying with the questions, is getting a better physiological understanding of what this is really telling us. So yeah, we that's one of these things where, again, naively we go, oh, we're going to take the year and learn this technique, but we're always going to be learning newer techniques and gaining a better understanding of them.